Hello, welcome back to software engineering. Today, we're going to circle back to some of the earlier slides. So this is chapter 2. We're going to look at a few slides here, and then we're going to go on to chapter 3. Now, normally I introduce these at the beginning, but when I do that, typically nobody gets it. And this year I thought, well, let's just do everything first, and then we'll go back to them. Then by the time we go back to them, you'll know everything you need to know to process this information. So that's what we're doing here. Hopefully you have processed some of this requirements and design and all these different things, and how those steps look and all that good stuff. So let's talk a little bit about software engineering from the beginning then, and what we're doing, what was done historically, agile development in general, what is it? Go back through some of that knowledge. All right, so first let's look at some software process models. Historically, and we're talking like 60s, 70s, 80s, software was developed using the waterfall model. A lot of software is still developed using the waterfall model. I guess you can say common wisdom is that the most expensive, highest performing processes need to be developed with the waterfall model. So things like NASA and military systems still tend to be developed using the waterfall model, although a lot of people question whether or not that's a good idea. The waterfall model is a very rigorous plan-driven model. There are separate and distinct phases for specification and development, much like what we're doing in this class so far. So we had a very distinct requirements phase and a very distinct design phase. However, we've already gone back in the design phase and you've had to iterate on the requirements. We left the requirements phase knowing that the requirements were incomplete. We're going to leave the design phase knowing the design is incomplete. And we're going to go back to both of those as we go into further phases. So really what we're doing is incremental development. We're specifying, developing, and validating our software in interleaved portions. This could still be plan-driven or agile, but our process right now is definitely interleaved. And remember when I said that requirements and design often go hand in hand? Well, that's also the same kind of thing I'm talking about, that when software is designed in an agile way instead of in a waterfall or a plan-driven way, steps often end up overlapping one another. Then we've got our integration and configuration. Here the system is assembled from parts. A lot of software is developed this way now because there are so many parts out there, and why reinvent the wheel? At a certain point you can say, all right, let me make this application that does a thing, and then you can go and do your research and realize every single thing that I need to make this application basically already exists. My job is to be the glue that patches them together. Many modern software engineering projects end up falling into this. Now you still have to make requirements, you still have to do a design, but even for some of your projects, you're thinking, how can I just take existing off-the-shelf stuff and glue it together to accomplish what I'm doing? So in practice, most large systems are developed using elements from all of these. You're going to be taking off-the-shelf parts, you're going to be interleaving parts of your development, and then also you're going to have distinct phases. So as we've gone through so far, we've tried to do the same. We've integrated kind of all three of these. But here's what the waterfall model looks like in principle. We do our requirements, we do our design, then we do our implementation and our testing, then we do our integration, our system testing, and then we do our operation and maintenance. So if these phases look familiar, no surprise, those are the phases that we're going through. Basically, you are here in the second phase there, and we're soon to be moving into the third, roughly waterfall. We've got our requirements analysis and definition first, then our system and software design, you are here, then implementation and unit testing, integration and system testing, operation and maintenance. Now the main drawback to the waterfall model is obviously that it's difficult to accommodate change once the process has started. In the waterfall model, since these are distinct phases, and you'll notice from the previous slide, we don't go backwards, generally speaking, except at the very end when we might fall back to the requirements phase in order to add to the system, maybe as part of maintenance. So we don't go backwards. Once we've made the requirements, we don't look at them again. And a lot of you are trying to develop in that manner. You're thinking, well, obviously I have enough to do already with this design process, or later on, obviously I have enough to do already with this implementation process. I don't want to also have to be going back and iterating on the previous phases. And indeed, that is the biggest drawback of Agile that you have to do all of these things at once, and that you have to wear many hats and juggle many techniques. But back to the waterfall model, your inflexible partitioning into distinct stages makes it difficult to respond in case the customer changes the requirements, changes their minds, or for some other reason the customer requirements change. So, like I said before, this model is generally appropriate for high-performance systems when the requirements are well understood and change will be fairly limited. So again, like NASA building a rocket, they know they want to get that rocket to a certain place. They're not going to suddenly change their mind and decide that they're going to build Tamagotchi instead of a rocket ship or something. They know what they're doing ahead of time, quite a bit ahead of time. And though the properties of the rocket might change, the goals and requirements of the software don't particularly shift in that situation, although you might envision situations where it would, and indeed all requirements change. There's no such thing as a system where you know all the requirements ahead of time. They're very well understood. That's kind of a myth in itself. And so you tend to only see the waterfall model in very large systems where the perception is that the plan-driven nature of it will help coordinate the work, which many have questioned and might not really be the case. With that, let's just skip on over to our next slideshow, the Agile Software Development slideshow. So Chapter 3, we're going to just gloss over incremental development and everything there. We don't really care about those terms in this class. What we care most about is basically Agile versus plan-driven or waterfall-styled models. So what is Agile? What is the goal here? Well, the goal is to develop a software quickly and effectively. So how do you develop software quickly and effectively and also cheaply and all the other things that we'd want to do? Quickly being probably the greatest of the concerns these days. If you're a startup, you have some amount of money that you've got invested in your organization, and when it's out, you're bankrupt. And if you don't have a product yet, well, you're done. If you're already a business and you're established, and you're investing in a product, you want to see a return on your product not 3 years from now, but as soon as possible. So the quicker you can finish your product in general, the quicker you can get a return. Is this to the detriment of the industry as a whole? Probably. Are all of you familiar with the buggy nature of modern software and how almost everything ships in an alpha or beta state? Almost assuredly. Cyberpunk 2077 is a testament to the industry moving to the end user is the alpha tester pattern of development that has become pretty much ubiquitous in this industry. So whether or not you think this is a good or a bad thing is up to you. Would you rather have it a year from now and better, or now and buggy? I guess the choice is yours. So anyway, rapid development is one of the biggest priorities today for almost every business. There are a few exceptions, really. Businesses operate in a fast-changing environment. It's practically impossible to produce a set of stable software requirements because the requirements keep changing from under your feet. You can think of basically any software you want to make. The requirements will probably be different a year from now, and the users will ask for more and more stuff. So there's really no point in doing a lot of long-term planning. Software has to evolve quickly to reflect the changing nature of business needs. So plan-driven development is essential for some, but not many, types of systems. It really doesn't meet the requirements of these fast-changing systems that describe almost everything. Agile development methods emerged in the late 90s when software is obviously taking off the most. We've got the dot-com boom, we've got all the different developments in the software industry. You've got object-oriented programming taking the lead, and Java growing to massive proportions, and all this cool stuff happening in the 90s. And we develop Agile development in order to radically reduce delivery time for working software systems. Notice that word working, very carefully chosen there, working. Not working well, not working perfectly, just working. Working is like the bare minimum that software can be, right? What's the least you can say about software? It works. But software working is better than it not working, right? So, and software that works is better than having no software at all. So while it's not exactly glowing praise, working software is better than nothing. Program specification, design, and implementation are interleaved in Agile development, so these processes run basically concurrently, and sometimes we'll go back to one, and sometimes we'll go back to another, and sometimes we'll do them at the same time. The system is developed as a series of versions and increments, basically, with the stakeholders involved in version specification and evaluation. So we're talking to stakeholders as we develop. We're trying to create a prototype as quickly as possible, and then we are iterating on it in small increments. So when we're developing in the Agile model, we're delivering new versions of the software frequently. You haven't delivered anything yet, which doesn't make you very agile at all. But of course, if I asked you to deliver most of the things that we've specified so far, it would be quite the disaster, wouldn't it? So there is something to be said about planning a little bit ahead of time, even when you're doing Agile development. Agile development typically uses a lot of tooling, automated testing, automated generation of UML diagrams, different tools that support rapid development, and typically we're not going to write a lot of documentation, whereas in the waterfall model, every step of the way we write a little book on what we did. In Agile development, we're just going to steam on ahead, but minimal doesn't mean none. Okay, so make sure that your system is still documented enough that developers can understand what it does. Otherwise, your lack of documentation will become a debt that future developers have to repay, and it will slow down your development, not speed it up. So in the plan-based development process, we've got the requirements engineering and specification, design, and implementation. A requirements change request kicks us back to requirements engineering, and we have to start the process over again. Whereas in Agile development, we are constantly developing our requirements, designing and implementing the system, and then going back and making more requirements, designing and implementing those, and so on to infinity until we're done. Plan-driven approach based around separate, distinct stages. Now, again, not necessarily the waterfall model. You could have a plan-driven incremental development too, but let's just say that plan-driven or waterfall type models are typically what we're comparing against. Whereas in Agile development, we're specifying, designing, implementing, testing all at the same time. Wonderful. So for the rest of the semester, as we move into the implementation and testing phases, we are going to be Agile, and as you get to the end of this phase, you are going to be Agile, and you are going to have to perform maintenance on your requirements as you're doing maintenance on your design, as you're implementing to the extent that you're building your code skeleton and everything. You're going to be doing all three of those phases basically at the same time. So a little historical background again. 80s and 90s leads to the creation of Agile Methods because people are basically upset that software takes so long to write. You know, you're looking at years of delivery time and all these distinct steps, and it's a big, tedious chore. So people have some pretty simple ideas. Let's focus on the code. Let's get a prototype out quickly and iterate on it. And let's deliver working software fast and then evolve it over time. So you could describe this more negatively as let's deliver the minimum viable product, the minimum piece of junk that actually does what it's intended to do, and then slowly cobble it together into something that works. Can you imagine if cars, for example, were built using Agile development? We would just stick four wheels together with some metal pipes and say, look, it rolls, this is version 1. Next time we just strap a boat motor to the front of it and a propeller and somehow rig that up to the tires, that's version 2. Nobody's going to want to drive car version 1 through 300. So cars definitely are not developed using the Agile model. But software can be, because the minimum viable product usually isn't going to kill anybody, and it's better to have four wheels connected by metal pipes than to have to walk everywhere. So think about it that way too. The aim of Agile Methods was to reduce the overhead that was so popular in the 80s and early 90s, the mountains of documentation that you had to write for anything. Go back and look at some photographs of NASA workers from the 80s and 90s standing next to their code, and they have these giant stacks of paper that go beyond their head, and 90% of that is documentation and other paperwork. So let's look at the Agile Manifesto. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. While there is value in items on the right, we value the items on the left more. Okay, I think all of that pretty much speaks for itself. Some of the principles then described in more detail. Customer involvement. Obviously, customers should be closely involved in the development process. Many of you have stopped calling the customer, and the customer has become sad and lonely as a result. If you don't continue to involve the customer, especially as you continue to make decisions, then your vision will drift further and further from the vision that the customer has and make it more and more likely that what you deliver is not satisfactory. So, whenever you develop software, you need to constantly be in touch with your customer, at least if you're following the Agile process. And as you iterate and create new versions of your software or new versions of the requirements, you need to run those by the customer and make sure that they are acceptable. Incremental delivery, we'll get to this soon, hopefully, as part of our development process. We are delivering different parts of the system a piece at a time, running them by the customer, seeing that they're happy and that they meet the requirements that we wanted to include in that increment. Focusing on people, so the Agile process emphasizes interviewing stakeholders and a lot of these other things that we've discussed, especially in the requirements phase. Many of you have taken the stakeholders for granted and not necessarily spoken to them. You might be surprised further down the road when you inherit a project that also didn't talk to the stakeholders, and what you deliver ends up being extremely unsatisfactory to the people that it's actually supposed to serve. Embrace change. That's a fancy way of saying if the customer calls you up and asks for something new, the waterfall model cries because they've negotiated a fixed fee, and the Agile model cheers because they've negotiated an hourly fee, and it gives them the opportunity to accommodate those changes. That's a simplistic view of it, but not necessarily wrong. Maintain simplicity. Focus on simplicity in the software and in the development process. Don't make mountains of documentation. Try to be as simple as possible. Easy to say, hard to do. Could say a whole lot about simplicity. Product development, where the software company is developing a small or medium-sized product, is typically the recommended application of Agile, but virtually all software and applications are now developed using an Agile approach, with, again, the small exception of high-performance, large-scale systems. Look at a couple of Agile development techniques that I want you to use over the coming phases. Let me read some of their great comments so far before I move forward. We got a beautiful Humble bundle for front-end web development. That could be useful. Who knows what kind of books you get there. The books you get with Humble Bundle are usually kind of junk, but they're a good starting reference for the $1 or whatever that you pay for them. Somebody said, last time we embraced change, we lost points because we made our job too hard. Absolutely. Did you miss the last point there? Did you miss maintain simplicity? Embracing change doesn't mean embracing it for free or just for the sake of it. When we embrace change, we want to focus on change that the customer or the stakeholder wants. We want to do it in the simplest possible way, and we want to make sure that we get paid for it, generally speaking. Of course, in all of the cases that you guys have, you've negotiated for either a piece of the project's revenue, which means that you have a stake in getting it done as quickly as possible, or you negotiated for a fixed cost, which means you want to be as resistant to change as possible. The next comment is that 90% of what we've been taught so far is useless. No, everything you've been taught so far is how it's done in Agile development. What you should be concerned about is that not only would you be responsible for writing the requirements and doing the system design, but you would be writing the requirements, doing the system design, implementing it, and writing the tests all at the same time. That would be your job if you were a full-scale software developer. In fact, you might have to do all four on the same day, but it depends on how your organization is structured. You may very well have different people doing those different tasks. If you have different people doing those different tasks, then all those people have to talk to each other all the time with constant non-stop meetings. The requirements people have to meet with the design people and so forth. So what we've been doing these last few weeks is more like the waterfall model because we separated those into distinct phases, right? But if you were working in an agile company, you would still be doing those same things. You'd be generating the requirements document, writing the UML, generating the design document, generating the class documents. You would just be doing all of that at the same time, or you would be doing all of that while talking to other teams doing the other stuff. So maybe you're on the design and somebody else is on the requirements. So that's what I'm saying. I'm saying that in a true agile system, you wouldn't have 2 weeks to do the requirements, 2 weeks to do the design, a week to do the testing, 2 weeks to do the implementation. You'd be doing all of them together. But of course, if we did that, then I think it's pretty obvious what everybody would do. You'd probably neglect all the fancy diagrams and stuff and just write code as quickly as you can. Of course, we don't want that. I want you to do the fancy diagrams and stuff too. So it's not to say that everything you've learned is useless, but to say that be prepared for all of it to happen at a more rapid pace and with other responsibilities on your plate simultaneously. So looking at some agile development techniques, my favorite one, my favorite name at least, is extreme programming. That was my best guitar solo. This was a very influential Agile method developed in the late 90s, and it takes an extreme approach to iterative programming, where new versions of your product might be built several times a day. You deliver a new version of your product to the customer every couple weeks, and you develop a series of tests for your product as you're writing it. And every time you build a new version of your product, you run all your tests again. You run a series of automated tests, obviously not manual tests, and the build is accepted if the tests run successfully. So the next phase we're going to be going into, we're going to be writing those kinds of tests, and then we're going to take our extreme type agile programming type implementation to another level. So let's look at the extreme programming release cycle. We select some user stories that we're going to try to accomplish for this release. We break down those stories into tasks that we're going to accomplish. Then we plan our release, develop and integrate and test the software, release it to the customer, let the customer evaluate it, and we evaluate it. And then we go back to the beginning. So extreme programming, based very heavily on user stories. Have a lot of you emphasize the user stories? Not so much, but now you've gone back and you've read them over. Is the software that you're planning to do going to meet the user story that was written for you? For some of you, maybe. Break that story down into the tasks you have to accomplish, and then figure out how you're going to integrate those into the software you have. That's the extreme way. So we've got a lot of different things that are happening here. First of all, incremental planning, one story at a time, small releases, a few stories at a time, and just a couple pieces of functionality at a time. We see that minimum useful set of functionality phrasing again. A lot of the time you'll see that expressed as minimum viable product, MVP, or various other buzzwords. That term tends to change every few years. But every generation we're just adding a little bit more functionality, a little bit more simple design additions. Extreme is a test-driven development process because we need to build that automated testing framework in order to verify that our new piece of functionality didn't break everything. We're going to learn to write tests before we write software in the next section. That's going to be based significantly on the code skeleton produced in this section, so make sure you do a good job on that guy, and on your class diagrams, of course. You'll notice that planning is still part of extreme programming, so the class diagrams and the other kind of planning is still very much a part of it, although, of course, you only have 2 weeks to actually deliver something. You guys are way over time budget. Refactoring. Developers are expected to refactor code continuously. What does that mean? Man, well, you got your class diagram. Let's say you've decided that the doohickey method on the widget actually belongs in the doodad. Well, time to move it and do all of the other wonderful code rearrangement that it entails to move that method. That means also updating your class diagrams and everything else, which means that all of that stuff probably should be automated. Otherwise, it's going to take us a very long time to accomplish those tasks. So we're constantly refactoring our code to make improvements with the goal of keeping it simple and maintainable, and the true end result of often making an unintelligible pile of spaghetti, but we're not going to mention that downside here. Extreme programming practices: pair programming, collective ownership, continuous integration, sustainable pace, and on-site customer. A lot of these are dreamy. I think we go into more detail in other slides, so let's go on for a bit here. We've already did that. I think we've already talked about that. We've done enough on user stories already. You should be familiar with those. You've already seen a few examples of stories. In addition to stories, we might also make these kinds of task cards, which describe what a person might have to do. So this is sort of the story form of a task. That should be pretty familiar if you're familiar with the user stories already. Refactoring, I think, will become clearer as we get into the implementation phase, so we'll probably double back to that. And let's talk about test-first development a little bit, because that's what we're going to go into next. We're not actually going to go into implementation right away. We're going to go into testing before we go into implementation. Now, test-driven development, or test-first development, sometimes abbreviated TDD if we're talking about test-driven development, has become really popular relatively recently. And test-driven development was also popular in extreme programming. Basically, what we do when we're testing first is that we write all of the tests that we want our software to pass before we write the software that does them. So we write the tests that verify that the software does what it's supposed to do before we write the code that actually does what it's supposed to do. This is going to be really strange and unfamiliar, but I want you to keep it in mind a little bit as you are writing the code skeleton and finishing up your class diagrams. How do I verify that this class, so whichever class you've written, works correctly? If you have a class that is very, very large, or you have a class that is very, very small and has very few fields, then perhaps you should rethink that, because as you're designing your classes, one of the things to keep in mind is, how do you verify that this class works correctly? And if you don't have any way to do that, then perhaps you have not done your class structuring correctly at all. Of course, we're going to use automated testing here. We're going to write a few very low-budget automated tests ourselves. Writing tests before you write the code clarifies the requirements to be implemented. You can pair tests with non-functional requirements very easily, and you can pair tests with functional requirements too, depending on what they are. Tests are written as programs rather than as data, so they can be implemented automatically. So our tests are code. In other models, we have test data that we feed into our application. That's not what we're talking about here. We're talking about testing code that automatically executes certain parts of our program, makes sure that the output is produced correctly, lets us know what went wrong if it isn't. This is going to be bog standard in the industry. If your organization doesn't have that kind of automated testing, you are going to have a pretty miserable time, because you're going to spend your entire day squashing bugs. Previous and new tests are run every time when we develop new functionality. So when we write new functionality, we also write new tests. But we also have to make sure that the software passes the old tests. So as we write more and more software, the tests add up more and more. So not only do we have our compilation time and everything for the application, then it also needs to pass the tests. This actually becomes quite a pain point at a certain point in development. When it takes 10 or 20 minutes for your test to execute, it'd be quite a pain in the butt. But when it takes 3 or 4 hours for all your tests to execute, then it can really be a pain in the butt. And especially if you need to test things like threading faults, well, those tests you should probably run for several hours to verify that there's no issues, and that can be quite time-consuming. What's the role of the customer? As with other Agile models, the role of the customer is to help you develop those tests, tell you their stories that will be implemented in the next release. The customer, who's part of the team, writes tests as development proceeds. All code is validated to ensure that it's what the customer needs. So before we move on to the next functionality, we can validate that the customer's user story was successfully satisfied. But of course, customers have limited time available. They can't work full time with you. That's not going to be an issue here. A company co has nothing but time on their hands. Test case description, we're going to skip over that. Test automation, I think we talked about that enough. Problems with test-first development then. So what are the downsides to doing it this way, and how can we avoid some of these? Programmers prefer programming to testing. I think that's fair to say. I think it's probably fair to say of all of you. I think you would much rather write code than write the tests for it. So if I gave you a homework assignment, like, I don't know, calculate the square root of a given integer, you would be much more comfortable writing the actual code that does that, calculates the square root of a given integer, than writing all the tests involved for it. So what are the tests involved for writing the square root of an integer? They're actually much more involved in the code. They're probably 10 times longer. What do you do for 0? What do you do for negatives? What do you do for max int? What do you do for min int? What do you do for overflows? What do you do for what do you do for decimals? I don't know. All kinds of different stuff you have to think about that you could get as inputs. All kinds of outputs to verify. How do you confirm that the answer is the square root? Well, if it's the square root, then the number squared must equal the original number, but you're doing integer math, so it doesn't necessarily because of rounding. So now how do you confirm that you're actually getting the right output? Well, your problem now. So obviously, most of you are going to prefer to write code versus testing, and this is going to be true probably of the majority of developers. And because of that, developers tend to take shortcuts when writing tests, and incomplete tests that don't check for all the different possibilities and all the different possible exceptions that might occur end up being more trouble than they're worth sometimes. Tests can be really difficult to write incrementally, especially when user interfaces are involved. If, for example, a button needs to do something when it's clicked, how do you write a test for clicking a button that's automated? Well, you have to use some kind of automated clicker tool. What do you do? That's a very complicated question, and the industry has not done well at answering it necessarily. There are tools out there that help you automated test your UI, but none of them are great. So it's not really something that's really been answered yet in the industry. And it's difficult to judge the completeness of your tests. It's hard to know when you're done. The unknown unknowns, as they say, are the most difficult ones. The tests you haven't thought of are probably going to be the hardest of all, the most gnarly bugs to fix. Brings us to a couple of other cool things in Agile development. But we'll talk about these another day. I think I've talked to you enough today. I'll leave you to work on your design some more. And remember, you've got an exam Wednesday next week. The design phase is going to finish up on Monday, and we're going to pick our new teams for that test development phase. And then we are going to have the exam, and we'll start the new phase the following Monday. So have your design document finished up by Monday and be ready for the exam. Any questions about the exam, feel free to direct those to the general chat. It's going to be about everything you've learned so far, Agile development, all the different UML diagrams, requirements in general, design, the 5 views, user system requirements, functional, non-functional, all these different things. All right, see you in Discord.